So here is one that we were actually asked to find. 4 root 3 plus 4i, and in this case I want fourth roots. That's what that n equals 4 is there to help us find. So first things first, we need polar form. In order to get polar form, we need to find our modulus, which again is an absolute value, same idea. Pythagorean theorem will help us out here. So I'm going to square my 4 root 3, and I'm also going to square that 4. Simplifying that, and just in the interest of time, that's going to be 8. We also need to find theta. So tangent is going to be the function we want here, inverse tangent, and it's inverse tangent of 4 over 4 root 3. Note those 4's will cancel, so when you go to do your unit circle lookup, you're really just going to be looking for 1 over root 3, which is the same as root 3 over 3. That's what you'll be looking for on your unit circle. Keep in mind this is a quadrant 1 complex number, so you're looking in quadrant 1. The angle which makes that true is pi over 6. So our polar form is going to be 8, that's our modulus, cosine of our angle, that's pi over 6, and then we have an I sine of pi over 6. If you didn't follow any of these steps, I encourage you to go back and rewatch the videos for how you get a rectangular complex number into polar form. It's explained much slower there. But in the interest of time, I wanted to go through this one a little bit quicker. So now we have our polar form. We are being asked to find the fourth roots. Well, that's the same thing as saying, hey, what's this? So note that because I'm taking a fourth root, there are going to be there are going to be 4 k values I care about, but they're going to start at 0 and then end at 3. Because we start counting at 0, we only need to go up to 3. So these 4 values for k are going to determine all the work from here on out. So I'm going to need a k equals 0, all the way down to k equals 3. This is where we find out how well I can organize this much space. All right. So part of your formula is you actually have to take the radical of the modulus. Unfortunately, 8 is not a perfect fourth. So that will be something the calculator needs to help us with later. So there will be a fourth root of 8 for all of these. Because my modulus was 1 in the previous example, we didn't have to worry about it as much as we will this time around. So we're going to have that fourth root of 8 coming into play. We will also need cosine and I sine. And once all your work is set up, you can start thinking about that fraction. So first things first, I need my theta, my angle. I'm going to go ahead and actually write it in this time. Theta is pi over 6. We'll be dividing that theta by n, and n in this example is 4. It's the same 4 that they gave us in the very beginning here, which it looks like I actually made green. So let's keep with the green tradition here. And to that theta, that pi over 6 back upstairs in the numerator, we're going to add 2 pi and then the value of k. Go ahead and make that purple this time around. So the first time we do this, that k is going to be 0. But in subsequent iterations, k will be 1 or 2 or 3. So the only thing that's really going to change here is that k, which means if you are on a computer, copy and paste is a pretty slick trick. So when k is 0, we have all of these k values being 0. When k is 1, well, that just means in that numerator you're multiplying 2 pi by 1. I can at least clean these up. When we come down and k is 2, again, that just means that you are now multiplying that numerator by a 2. And last but not least, when k is 3, you guessed it, we'll be multiplying that 2 pi by 3. That one didn't quite go right. Good times. So at this point, we have our 4 different roots set up, but we still don't know what they are. So we can jump over to the calculator now. The calculator can help us out. And again, I recommend finding all the real parts first, and then switching over to finding all the imaginary parts. That way, all you have to do is change one number in your calculator with each iteration. Keep in mind, there's more going on this time around. We also need to take into account that 4th root of 8. So a couple of different ways you could do that in your calculator. For me, I feel like the quickest is to just type 8, that caret key, and then actually enter it in as 1/4. So now your calculator will include that 8 to the 1/4 with every one of your calculations. So we want 8 to the 1/4 times cosine. Again, we're starting with all of our real parts. Cosine of a fraction, and our theta was pi over 6. Again, don't get overwhelmed in the numbers here. Ooh, like I just did. Don't get overwhelmed in the numbers here. These are coming right from the work we do by hand. The reason we set anything up at all by hand is it makes it easy then to transfer our work to the technology so the technology can work. So I've got pi over 6. To that, I am adding that 2 pi times 0. Of course, the first time I do it, and that's just going to make that whole term a 0. And we're dividing by 4. So getting our 4 real terms here, that's the first one. We can switch that 0 to a 1. That's my second one. Switch that 1 to a 2. And last but not least, we can switch it to a 3. So we have our 4 real parts. In the interest of time, I'm just going to go ahead and put those back into the slides. So there, highlighted in blue, we have all 4 of our real parts. And there's the bottom one. So now let's go ahead and find our imaginary parts. The big shift here is instead of cosine, I'm going to want sine. So I'll change that 3 back to a 0, because we're going to restart the whole iteration. And instead of cosine, we want sine. So just like last time, hitting enter on the calculator, let the robots do the robot work. And that was slick. Didn't screw up once. So now we have our 4 imaginary parts. Again, I'll go ahead and just enter those on the slides. And we now have our 4 imaginary parts, all highlighted in that pink color there. Keep in mind, this is a video. You can always rewind or hit pause. So we have our first root, second root, third root, and fourth root. If you want to double check whether or not one of these is correct, you can always put it back into your calculator. You could also sketch just a quick little graph. Keep in mind it won't be super accurate, but you can always sketch a graph and make sure you actually can observe the symmetry you're expecting. For example, one of my points was at 1.67 and then 0.22, so that's going to be over here somewhere. The next one is at negative 0.22, 1.67. So that's going to be here somewhere. We'll have one at negative 1.67, negative 0.22, down there ways. And last but not least, 0.22, negative 1.67. So if this was more accurate, you'd probably be able to see that symmetry a little bit better. But keep in mind, because we split that coordinate plane up into 4 pieces, there's 90-degree symmetry here between each one of these points. You can also think about it this way. Nice right angles. So there's a lot going on in the complex plane, and this is the reason we spent this week looking at it. All of these symmetries come back into play in other chapters and other units as well. And if you go further in math, you will play with this idea of symmetry a lot. We're not always just looking at x-axis and y-axis symmetry. There are other kinds of symmetry, and this is just dipping our toes into the wonderful pool of advanced mathematics. But that's all for now. I get it. This is more than we usually ask you to do. So take a deep breath and hold it. And just think about how wonderful spring break will be. I'll see you tomorrow. Have a fantastic day.